Before beginning this assessment, we selected our group members based on compatibility and willingness to contribute to the group. After this, we organised team meetings in which we would design, discuss and begin constructing the bridge. Within the early stages, some of our discussions were held during class, making small agreements and decisions leading to starting the construction. As a group, we collectively brought all necessary materials, including the plaster and superglue, and split the costs evenly. This would then lead us to begin designing our bridge. Researching common bridge types as well as prior spaghetti bridge designs were pivotal in arriving at our first concept design. This concept was to replicate the current world record spaghetti bridge, which was our main inspiration through the beginning stages. Within our first official meeting, we utilized the university facilities and began formulating concept sketches which would assist in construction of our bridge. These sketches were heavily reliant on the world record bridge. However, these were only rough sketches at this stage. Following this, measurements and member lengths and widths were calculated and were agreed upon in order to begin constructing. At this stage, we could finally begin the cutting pieces of plaster accordingly and begin the construction stage.
In order to better allow us to handle the members with ease whilst the glue was drying, baking paper was used to not have our hands stick to the pieces. This was found to be a pivotal technique as we had encountered numerous breakages of members who were sticking to our hands while they were drying. We worked collaboratively to draw the bridge to scale utilising our chosen design, which we would use to construct the bridge and use as a template. The pieces of pasta were measured and marked with a pencil in order to indicate where to cut. These pieces were bundled together and superglued to add thickness and increase the capacity which they could bear. Thus our bridge began to take shape. We were able to test this initial concept, however failed with ease, with the joints of the bridge not strong enough to bear the load. We then decided, in order to secure the joints efficiently and effectively, to construct gang nail plates from pasta and superglue the joints for our next bridge. Our final concept was altered in design to withstand more load, with an increased width of each member. Additional gang nail plates, a strengthened member which would sit horizontally across the centre of the base of the bridge.
After completing the construction of our bridge, we had our final meeting in which we would test the bridge and record the results. However, there was a lapse in communication as the bridge was too short according to our measurements, hence our bridge fell between the two ledges in which one member broke. We agreed this was not vital to the strength of our bridge, as the thickened horizontal piece and gang nail plates brought a surplus of strength. Additionally, the plate was unable to sit properly across the centre of our bridge as a result of the centrepiece. This then affected the bridge's performance as the plate shifted upon increasing the load and therefore cutting our test short. We can conclude that our bridge could bear more load because it never broke, especially if we were able to continue testing. The final weight of the bridge was 179.61 grams with a final load capacity of 0.06 kilonewtons.
Reflecting on the process, we can agree that our bridge had many areas of weakness. However, it could have been tested further until proper failure. If our bridge was constructed to length, we estimate it would have more leverage against the load being applied and therefore would be stronger. Additionally, it appeared that the smaller sized members worked more effectively in bearing the load as there was less compression force being applied. However, our bridge was strengthened by thickened members and gang nail plates, and to further strengthen these pieces, additional superglue was applied. The gang nail plates proved to be very advantageous as it gave a large surface area for the members and glue to stick to. In the future, a larger emphasis would be focusing on every detail in order to avoid small mistakes and time wasting. All group members learned a lot about how loads are distributed and how they interact with different members and joints, including the failure points and limits of each material.